And we'll try to solve this question number 5. The question asks us to find the energy stored on this capacitor. But let's read the question first. So with battery of voltage V attached, there's 2 joules of energy stored on the initial state capacitor, which is this one. Without removing the battery, the dielectric is inserted between the plates with dielectric constant of 2. And this occupies the half of the volume of the capacitor shown. So let's take a look at the initial state first. The initial state electric field is given by voltage drop between 2 plates divided by the distance between 2 plates. And we can also get the energy stored between on these capacitors for initial state, and it's given by 2 joules right here. And the equation for that is 1/2 permittivity of free space, electric field between it, and SC. And let's also take a look at the final stage after the dielectric is inserted between 2 plates. So let's denote this electric field for this part, free space, as E1, electric field that is in the space where dielectric is inserted as E2. The voltage drop between 2 plates is given by this integral. This integral is path independent, which means whichever path you take for this integral have to always get the same answers. Which means, in other words, E1, E2 must equal. And this value is voltage drop divided by the distance between it, because it's the general formula for the electric field between 2 capacitors, 2 plates, sorry. And because there's no changes in voltage and distance between 2 plates, this will be also equivalent for to electric field in the initial state. So we can write down the energy stored on the final state. This is going to be the summation of summation of this part and this part. So this is a this regards to the free space right here, and this is ST over 2 because the dielectric here occupies exactly half of the volume of the capacitor. And this part is regards to the space where the dielectric is inserted. So that we have dielectric constant 2 right here. And this is also ST over 2 because it occupies the half of the volume. If you further simplify it, 2, it's going to be 3 over 4 permittivity of the free space multiplied by electric field initial. The reason we use we could use electric field for the initial state because we all agreed in the first place that E1 equals E2, and that is also equivalent to EI, initial state electric field. So if you look at the ratio between energy stored in the final state and initial state, we all have this equation for each situation, so that's going to help us further simplify the situation. So we can erase this part. So the ratio between the final state and initial state will be sorry, 3/2. So energy stored on the capacitor in final state will be 3/2 multiplied by um, the energy stored in the initial state capacitor. And this value, we all know this value because it is given by the question right here, 2 joules. So if we plug in this number, the answer we were looking for would be 3 joules. This is the answer for this question, which is the energy stored on a capacitor after the dielectric is inserted between 2 plates.